Hello everyone, in this video I will explain the delta method for finding derivatives. So in the previous video we found that if you want to find the slope of a tangent, so m is for slope, so slope of a tangent is limit h approaches to 0 f of x plus h minus fx over h. So the limit on the right is defined as the derivative of fx at x. So this is one of the fundamental definitions of calculus. So this is also the instantaneous rate of change of y with respect to x. And the different notations that we use for this are dy over dx. So usually we use this notation. So this is the most commonly used notation. This is simply a shorter way of writing limit delta x approaching to 0 delta y over delta x. There are other ways of representing the derivative. So instantaneous slope or slope of tangent at a point, slope at single point, slope of tangent line. So there are different ways we call the derivatives. And the different notations are d over dx of y or f prime x or dxy or y prime. So these are all the notations that we use to write derivative. D over dx or this dx, so they represent the process of finding or the operation of taking the derivative with respect to change in variable x. So in delta method, we're going to use the definition of derivative. So the derivative is given by, so f prime x is equal to limit of h approaches to 0, f of x plus h minus fx over h. So as I said earlier in the previous video that this expression f of x plus h minus fx over h, so this expression is called difference quotient. Difference quotient, and I'm just going to write this as dq. In order to find the derivative using the delta method, we're going to follow the following steps. So first step is write down the difference quotient and substitute the function in the difference quotient. Then simplify the difference quotient, and the last step is you process the limit, and this will give us the value of the derivative function in the end. So let's do a few examples where we're going to apply the delta method. So first one is find the derivative of the function x cubed plus 2x minus 1. So recall that the difference quotient is f of x plus h minus f of x over h. And then we fill in the terms of dq from the given function. So in this case, so let's try to find what is f of x plus h. So simply wherever we have x in the function, so now the input is going to be x plus h. So replace all the inputs by x plus h. So we have written the values of f of x plus h minus f of x over h. So now we're going to simplify it. So in order to simplify x plus h whole cube, so either you can use the formula if you remember it, or you can just do the expansion. We can think of this as x plus h square times x plus h, and we cannot write this expansion. So x plus h whole square is a square plus 2ab plus b square. times x plus h, and then we have plus 2 times x plus h, which we can just expand, 2x plus h minus 1 minus x cubed, and bring this negative inside. So negative times positive, negative 2x, negative times negative is positive 1 over h. So in the next step, we can expand this. So we're gonna first multiply x squared with every term in the second bracket. So x squared times x gives you x cubed. X squared times h give you x squared h, plus similarly you can bring this 2xh with every term inside the second bracket. So we have 2x squared h plus 2xh squared, and similarly the last one is h squared times x and h cubed. H squared x plus h cubed, and here we see that 2x and 2x cancels, 1 and 1 cancels, and we are left with plus 2h minus x cubed over h. So now we're going to combine any like terms that we can. So in this step, we see that we have a positive x cubed here and a negative x cubed here, so that cancels out. And then we have x squared h plus 2x squared h, which gives us 3x squared h. So these two terms together give us 3x squared h. Similarly, we have 2x h squared plus h squared x. So these are again like terms. So we got 3x and h squared. And then we have h cubed, and we have 2h over h. So one thing we see here is, so h is a common factor. So h, inside you have 3x squared plus 3xh plus h squared plus 2 over h. H and h cancels out, and we are left with 3x squared plus 3xh plus h squared plus 2 in the end. So this is our simplified difference quotient. After simplification, the last step is take the limit as h approaches to 0. So limit as h approaches to 0 of 3x squared plus 3xh plus h squared plus 2. So when we plug in the limit, we see that 3x squared, and then this expression becomes 0 and this becomes 0. So we are left with 3x squared plus 2. So this is our derivative of the given expression. So this was the delta method of finding limits. So we will plug in the values of the function in the difference quotient. We simplify it, and in the end we apply the limit as h approaches to 0. So let's do a few more practice examples. So in this one, fx is equal to 1 over x, and we have to find the derivative. So first thing we know is the difference quotient is given by f of x plus h minus f of x over h. And if you want to write the value of f of x plus h, so the input you're going to replace by x plus h. So we get 1 over x plus h minus fx is same, whole thing divided by h. And now we have to simplify this. So in the numerator, we have difference of two fractions. So it means we need to find the common denominator so that we can bring these two fractions together. I can rewrite this as 1 over h, and I have 1 over x plus h minus 1 over x. So common denominator in this case would be x times x plus h. So I can rewrite my expression as, so since I need another x plus h is already there, but we need to bring x here, so divide by x, multiply by x, and 1 times x is just x. Similarly, here we already have x, but we need x plus h, so again we're gonna multiply by x plus h in the numerator. So bringing the fractions together, so in the denominator we have x plus h times x, and in the numerator we have x minus h. So be careful, sometimes people don't change this to negative in this step and then they make a mistake. So don't make the same mistake. In this case, x and x cancels, so we are left with negative 1 over h. On the top we have negative h, and then we have x plus h. Here h and h cancels, and in the end we get negative 1 over x plus h. So this is our simplified expression of difference quotient. So in the next step, once we simplified it, we're gonna take the limit as h approaches to 0. So therefore, the derivative would be limit h approaches to 0 of difference quotient. So let's just apply the limit. So when I plug in the value, so we get negative 1 over x plus 0. So x times x is x squared, so negative 1 over x squared. So this is the derivative of 1 over x. So this is the required solution. There is another problem which I have given here for the practice. So make sure you practice this problem and you try to find the derivative using the delta method of derivatives. And I can tell you in the end you should get, the answer should be 2x minus 3. Thanks for watching my video and learning delta method for finding derivatives. I hope you enjoyed it. So in the next video, I will discuss the derivative rules. Those are the simple rules which help you to calculate the derivatives quickly. In real life, we don't use the delta method because it's very tedious.